We're going to continue on with our logarithm properties today, and yesterday we spent time expanding logarithms using properties. Well, today we're going to condense logarithms using properties. And so therefore, basically, it's just using our same properties for expanding backwards. We're going to take things that are already in expanded form and condense them down into a single logarithm. So today, the big thing to make sure of is your answers should always be single logarithms, and there should never be a number in front of the logarithm. That is something to make sure. That's how you will know when you are done with your answer. So we're just going to look at two quick examples, a very short video today for condensing logarithms. Example 1 is going to be to condense a logarithm like 4 log base 2 of x minus 2 log base 2 of y. We're going to again be using those rules we did yesterday backwards. So therefore, we need to recognize these values in front, the 4 and the 2. Those values in front were pulled out of an exponent using our power rule from yesterday. Says that the log base 2 of x to the 4th is the same as 4 times log base 2 of x minus log base 2 of y to the 2nd power. We also had a property that involved subtraction of logarithms that said if you have a log that is divided, if you are dividing the values inside of a log, you can write it as 2 separate logs using subtraction. Well, we're going to use that rule backwards. We have 2 separate logs of the same base. They have to both be base 2. We have 2 separate logs of the same base subtracted. That means we can write those as a single log using division. X to the 4th over y squared. There is our answer. It is important your answer has only one log in it and there are no numbers in front, because all of those numbers in front have become exponents. Example 2 is one that tends to cause people a lot of stress. When you're asked to condense a problem such as this, log base 5 of x minus 6, y minus log base 2 of x, all divided by 3. And the big issue comes in with this concept of division. What we need to understand is the division is the same as multiplying by a fraction. So therefore, I'm going to rewrite this as 1/3 times log base 5 of x minus 6 minus log base 2 of x. And what that does is now, instead of thinking it is divided by 3, I now have a times 1/3. So that functions like the power rule. I have that number in front that can become an exponent. First, we need to do what's inside the parentheses. Oh, and as you can see, I've made a typo on this problem. I could not put those together the way they look. So let's change that original problem to log base 5 for both of them, because that problem I made up is inaccurate. It would not have been able to condense them. They have to have the same base. So now, I have 2 logs that are both log base 5 and I'm subtracting. That means I can write those as a single log using division. Log base 5 of x minus 6 over x. And we still have that 1/3 in front. That 1/3 moves up to become an exponent on what you're taking the log of, to give log base 5 of x minus 6 over x to the 1/3 power. However, we're not going to leave an answer with a 1/3 power on it, because as hopefully at this point you understand that 1/3 power is another way to write the cubed root. So that is our answer, log base 5 of the cubed root of x minus 6 over x. So this is condensing. If you were able to understand our rules for expanding logarithms yesterday, condensing is something that is the same exact rules, just going the other direction.